All right. And 11.5 is going to go back to our traditional style of the note pages, because there was not a PDF or a PowerPoint for this one, so we're gonna have to go old school. All right, so we're looking at rotation of axis in the general form of a conic. I feel like the primary reason why this is typically not covered in the other sections is they probably have a harder time than I do because I teach a little bit quicker. And additionally, I think it's just been hard for everyone, being not in the classroom. But regardless, we are going to go through 11.5 today. If we have time, which I'm sure we will start 11.6. I don't know if we'll get through all of it. All right, so identifying conics, and here's the big thing. It's without completing the square. Okay, so if you wouldn't pay attention to this section, or if you didn't know about this section, in order to figure out, what classification these conics would have, you would have to complete the square for both the x's and the y's, and then get it into standard form, and then from there be able to pick whether it's a parabola, ellipse, or a hyperbola. But if we go with these approaches, you're going to find that it's going to be a lot quicker. So we have a, which always goes with x squared. For some reason, they leave out the b here. We get it later on, but I guess they're just assuming it would be 0 for this case. But b goes with the xy set. Okay. All right. A and C cannot both be equal to 0. If that happens, then we are no longer within this set of parameters, okay? And this is how we find it. If we take A times C and it's equal to 0, then the equation you're working with is a parabola. If we take A times C and it's greater than 0, then you're dealing with an ellipse or a circle. And if we take A times C and it's greater than 0, or sorry, less than 0, then when we're working with a hyperbola. Now, the reason why it can be either an ellipse or a circle is obviously because a circle is technically the nicest form of an ellipse. Ellipse, sorry. Okay. All right. I'm going to assume that since we're recording, if you guys didn't get that, then you can look at the video later. I will also take a screenshot of it. All right. Okay, so here are some examples for us. Okay. All right. If we're looking at option A here, example 1, option A, it says negative 5x squared plus 8x minus 7y plus 4 equals 0. So what's my A value?
-5.
Mm-hmm. So what do you recognize is your C?
0.
0, very good. So then when we take A times C, we're really doing -5 times 0, which gives us a 0. And that means what kind of situation do we have from that equation?
A parabola.
Mhm. Very good. Okay. All right. Someone else walk me through the second one. Walk me through option B. We know we're looking for A and we're looking for C. Then we're going to multiply them. And that will let us figure out what we're looking at. So what do we got for A and C? Somebody let me know. I know somebody can give me the pieces. A goes with the x squared. So what are we looking at there?
If it goes with x squared, then it's going to be -2.
Mm-hmm.
And then
And then
wouldn't
this.
C be -3?
Mm-hmm.
So then you'd be multiplying -3 by -2, and that'd be +6.
Excellent. And if we have a positive, then what's our classification going to be? If it's greater than 0. Cole, we're working on section 11.5. And we just discussed that if you take A times C and you get a 0 out of it, then we get a parabola. If we take A times C and it's greater than 0, we actually end up with an ellipse or a circle. And then what do you guys think the last one's going to end up showing us?
A hyperbola.
Yep. Which I could be wrong, but I'm pretty sure the entire time, the last 2 classes, I've just straight up been calling that a parabola. Which we all know that's not the case. All right, so 1 times a -2 will give us a -2. So it's less than 0. So we have the hyperbola. All right. All right, anybody have any questions on that? Pretty easy, I think. I might create a homework for this in Pearson. I haven't really decided. I'm feeling like the reason why it's typically not covered is due to the fact that it's kind of like a slight repetition, but I feel like you guys are totally okay with it. All right. So I had a little bit of trouble figuring out what exactly they wanted from me for the rotation theorem. And I ended up writing down a couple of them because it kind of builds. So I will give you just what they wanted, and then if you can't really see where it's coming from, I can give you the other two equations. So basically, we're looking at x prime cosine theta minus y prime sine theta. That's for the x. The y is very similar, but you have to pay attention to the small changes. So we have x prime sine theta plus y prime cosine theta. Okay, so we not only have a switch up of the trig functions, but we also have a change in the one is subtraction and the other is addition. And that is your rotation formula. Okay. So of course we're going to go through and work with it a little bit. We have x and we're going to find y. So we're working with the expression xy equal to 1 in terms of x prime, y prime coordinates by rotating the axis through an angle of 60 degrees, and we want to discuss the new equation. So we're going to go ahead and find x prime cosine. The theta we were given was 60 degrees. Minus y sine. Prime. And then it's very similar. We have sine now, 60 degrees plus. Okay. What do you think your next step's going to be? What's it make sense to do?
Like, simplify the trig functions.
Yeah, we're going to plug in what we know. So we know that the cosine of 60 degrees is 1/2. The sine of 60 degrees is the square root of 3/2. And then on the bottom, on the second part, it kind of flips. All right, I'm taking a picture of that, and then I'm gonna try to move it, but I don't know how it's gonna look, so we'll see what happens. Yeah, okay. So, all right, now that you know this is here, we're gonna go ahead and I'm gonna scroll down a little bit, or maybe I can zoom out. Nope. All right, we'll just get rid of it. All right, so hopefully you guys have that written down. So what do you think the next point is? We now have our x and our y. What did the problem want us to do with them? What did the problem ask us to do? We just found x and y, so now we have to do what? We're going to FOIL, right? What do you know is going to happen with your middle terms?
It's going to cancel out.
They're going to cancel out. Very good. Okay, so when you FOIL, you only have to worry about the first times the first and the last times the last. So the square root of 3 over 2 times 1/2 is going to give us the square root of 3 over 4. And it's times x prime squared. That is not x to the 12th. That is x prime squared. Minus the same thing, square root of 3 over 4 y prime squared equal to 1. Okay, so if we want to discuss the new equation, which we have right here, I went over to, does everybody have everything? Hopefully. I went over to Symbol Lab. Can you guys see this? I'm assuming it's sharing. If not, I'll share it again. Okay, so when we plug this in, this is what we get out. It's our graph of what we get out. And then you can see that it does still have a center at 0, 0, but then you can tell the asymptotes as well. Okay. This is a really cool website. It's pretty good. All right, let's go back. Here. Okay. And again, if I'm going too fast, you guys will have the video as well. All right, so if the angle through which to rotate is not given, the following theorem will allow us to identify the appropriate angle through which to rotate to remove the xy term from the equation. Okay, so it's one of our new theorems. All right. So to transform the equation, and you can see it all written out there, into an equation in x prime and y prime without the xy term, rotate the axes through an angle that satisfies the equation. So we have the cotangent of 2 theta equal to a minus c divided by b, where theta is the acute angle. We don't need to put a restriction on b because the equation itself already did that. You cannot have b equal to 0. So because of that, you don't have to worry. All right. Any questions on that? And apparently analyze the equation means to transform the given equation so that it contains no xy term and to graph the equation. So you're basically wanting to get rid of b. All right, so let's do that for this one. I did not draw out the graph. I will show it to you, but I used the symbol lab. Okay, so here's your equation. X squared plus 6xy plus y squared minus 7 equals 0. We want to rewrite the equation with no xy term. So what do you guys think we need to do there? And I kept everything in degrees. You guys don't have to do that. If you don't want to, you can try using radians if you like. I will get you to theta, and then it is on you guys to figure out how to rewrite the equation. I think you guys are up for it. So if we are looking at the cotangent of 2 theta, and we are equating that to a minus c over b, what am I filling in? What's my a?
It's A is 1, and then B is 6.
Yep. And c is,
Also 1.
oh sugar, it is also 1. Okay. So then 1 minus 1 will give us a 0. Oh, that's so much nicer. Okay, I'll have to rewrite that. All right, so now we have the 2 theta is equal to the cotangent inverse of 0. So what's 2 theta going to equal? What's the cotangent inverse of 0?
Won't that also be 1?
I believe so. Okay, so then we're looking at theta is going to be equal to 1/2. All right, so when does the cotangent equal 1/2? Ah. Okay, hold on. So the cotangent, the inverse of 0 happens at 90 degrees. Okay, half of 90 degrees will give us what?
45.
And now this is what we can do. Now we have to find x and y. Our x prime is going to be what? Cosine first, right? Cosine 45 degrees minus y bar sine, or y prime sine 45 degrees. And then y is equal to x prime sine 45 degrees plus y prime cosine 45 degrees. Okay, what do we know about that? We know that x is going to be equal to the square root of 2 over 2 times x bar, or x prime minus y prime. And then y is going to be equal to the square root of 2 over 2 x prime plus y prime. Then what do you guys think we have to do? I think I'm going to need a second sheet of paper. What do you guys think? We now have an x and a y. What was our equation written in? It was written in x's and y's, right? So now everywhere you see an x, you have to plug this part in, and everywhere you see a y, you have to plug the other part in. Okay? So I will give you guys bonus on your chapter 11 exam if you can email me the completion of this. All right, I want to see a graph. I want to see your final equation, the graph, and you can confirm it using a utility. And I will write down that this will give you bonus on chapter 11 exam. All right, sound good to me? Sound good to you? I will save it. All right, let's keep rolling. If you can't get it by Wednesday's class, somebody let me know and I will come back to this. All right. Okay, so here we have a x squared again, b xy, c y squared, and then it's dx ey and f. Okay. Now this is kind of going to look a little bit like the determinant. We're going to take b squared minus 4ac. If it equals 0, you're going to have a parabola. If it's greater than 0, you're going to have an ellipse or a circle. And if it is less than 0, you will have a hyperbola. All right. Any questions on that? Okay. All right. Here's our last example. If we have A equal to 1, B equals 3, and C equals -2. All right, we're going to plug that in. So B squared minus 4 times A times C. Okay. We end up with 9 plus 8. So that gives us a greater than 0 check. So then what is it? How do you classify this equation? Anybody?
A circle or ellipse.
Very good. Okay. All right. Let's see.